Hi, I'm Yu, a freshman at River High School, and this is PowerWise. The Midwestern power grid is getting more and more volatile with the onset of changing weather events and the expansion of facilities like data centers and EV charging. This makes it harder for policymakers to address the ongoing needs of the grid. PowerWise was created in response to this, aiming to pare down the technical barriers between policymakers and the grid through informed governance. PowerWise does this through real-time predictions, scenario synthesis, and a conversational interface powered by AI. Now, let's see it in action. This is PowerWise. As you can see here, these are the local resource zones of the Mid-Continent Independent System Operator. They're colored based on the amount of demand that they are drawing from their respective power grids. If I want to view a different point in time, then I can use this bar to select a different point in time, and you notice the colors update. If I want to view a specific number, then I can select this pop-up. Over here on the left is the custom feature dialog. So if I wanted to create a new feature, like a hypothetical data center, as part of the scenario synthesis I was describing earlier, you can see it pop up on the map. I'll create a factory complex as well. You may have noticed something blue across the bottom of the screen. This is the hourly demand plot. As you see here, the colors kind of switch to being lighter. Those are the predictions made by PowerWise's demand prediction model. If I ever wanted to zoom in a little bit to examine the data, then I can use the zoom in feature. Over here on the right is the AI chatbot. The AI chatbot knows exactly what's going on the map, so I can ask him how will the new factory complex affect the livelihoods of Wisconsiners. Then let AI think a little bit because it has some data to process. And you notice that it'll give a pretty comprehensive analysis of my prompt. So what it is telling me is that it might improve the economy, but it could also change a few things. So the policymaker can continue chatting with this in order to gain more context, as well as playing around with the rest of these tools. And that helps out with the informed governance. PowerWise's short-term grid predictions are made by an XGBoost regressor. The regressor was trained on around 90,000 rows of weather and demand data, which were sourced from OpenMedio and the U.S. Energy Information Administration. The data underwent several feature engineering steps to boost the model's performance. This resulted in a remarkable R-squared score of 99.4% for the testing dataset. PowerWise's backend consists of two processes, the API and the worker. The API, which is written in Python, provides the predictions and chatbot functionality to the front end. The worker, also written in Python, is to run hourly to make the predictions for the API. The front end is written in TypeScript and uses the Next.js framework. It displays the data provided by the API to the user in form of an app. Now I'll show you some of the code that went into making PowerWise. These are the Python notebooks that I used to develop PowerWise. These are used to fetch the training data and also to train the model. This is the worker. The worker runs hourly to fetch new data to make new predictions for the API. This is the API, which handles the chatbot functionality. The chatbot is Gemini 2.5 Flash model, by the way, and it also provides the prediction for the front end. And this is the front end. It's basically what everything the user sees. It handles data visualization and provides the chatbot UI. By bridging the gap between policy and the grid, PowerWise ensures that as the grid grows more volatile, our decisions become more informed.